Hello students, welcome to the lecture on quantitative techniques, and after the lecture we will be able to learn the following objectives. Understand the concept of quantitative techniques, explain the model building for business decisions, explain the role and scope of quantitative techniques, discuss the methodology of quantitative techniques, define the matrix algebra determination. Let's start with a brief introduction to the quantitative techniques. Quantitative techniques are those statistical and operational research techniques which help in the decision-making process, especially concerning business and industry. Managerial activities have become complex and it is necessary to make right decisions to avoid heavy losses. Whether it is a manufacturing unit or a service organization, the resources have to be utilized to its maximum in an efficient manner. The successful use of quantitative technique for management would help the organization in solving complex problems on time with greater accuracy and in the most economical way. Let's understand the concept of quantitative techniques. Quantitative techniques adopt a scientific approach to decision making. In this approach, past data is used in determining decisions that would prove most valuable in the future. We can use the scientific management analysis to find out how much the investments made will be worth in the future. Qualitative factors are important situations like sudden change in tax structures or the introduction of breakthrough technologies. Quantitative technique is a scientific way to managerial decision making, while emotion and guesswork are not part of the scientific management approach. This approach starts with data. Like raw material for a factory, this data is manipulated or processed into information that is valuable to people making decisions. Now we will talk about model building for business decisions. Managers can be trained to make better decisions. They also need a super environment where they would not be unfairly criticized for making wrong decisions and will receive proper support from their colleague and superiors. There are following types of the business decisions are: programmed decisions. These are standard decisions which always follow the same routine. As such, they can be written down into a series of fixed steps which anyone can follow. They could even be written as computer program. Non-programmed decisions. These are non-standard and non-routine. Each decision is not quite the same as any previous decision. Strategic decisions. These affect the long-term direction of the business, whether to take over company A or company B. Tactical decisions. These are medium-term decisions about how to implement strategy. For example, what kind of marketing to have or how many extra staff to recruit. Operational decisions. These are short-term decisions, also called administrative decisions, about how to implement the tactics. Model building for business decisions. Constraints on decision making. Here we will talk about constraints on decision making. Basically, there are two types of constraints that are defined in decision making. Internal constraints, which is availability of finance. Certain decisions will be rejected because they cost too much. Existing business policy. It is not always practical to rewrite business policy to accommodate one decision. People's abilities and feelings. A decision cannot be taken if it assumes higher skills than employees actually have, or if the decision is so unpopular no one will work properly on it. External constraints. These come from the business environment outside the business. Competitors' behavior and their likely response to decisions our business makes. Lack of technology, economic climate. Let's look at the quality of decision making. Good decision making comes from training of managers in decision making skills, good information in the first place, management skills in analyzing information and handling its shortcomings, experience and natural ability in decision making, risk and attitudes to risk. Human factors like emotional responses come before rational responses, and it is very difficult to get people to make rational decisions about things they feel very strongly about. Now we will know about the role of quantitative techniques. Many quantitative techniques can be successfully executed using fairly rudimentary data. Many of the available techniques, including for example switching analysis, bidding studies and shock analysis, can produce highly effective results with basic information. The intuitive and the accessible nature of these techniques means that they can be understood by a wide audience. It is undeniable that some of the more sophisticated techniques raise complicated technical issues and require considerable expertise on the part of the practitioner. However, precisely because of their sophistication, these techniques can yield exact answers to the questions that are pivotal to the competition cases. Let's talk about the scope of quantitative techniques. The scope and areas of application of scientific management are very wide in engineering and management studies. A few specific areas are mentioned as finance and accounting, cash flow analysis, capital budgeting, dividend and portfolio management, financial planning, marketing management, the selection of product mix, sales resources allocation and assignments, production management, the facilities planning, manufacturing, aggregate planning, inventory control, quality control, work scheduling, job sequencing, maintenance and project planning and scheduling. Personnel management, manpower planning, resource allocation, staffing, scheduling of training programs. General management, decision support system and the management of information systems, MIS. Organizational design and control, software process management and knowledge management. The methodology adopted in solving problems is as follows. Formulating the problem. As a first step, it is necessary to clearly understand the problem situations. It is important to know how it is characterized and what is required to be determined. Firstly, the key decision and the objective of the problem must be identified from the problem. Defining the decision variables and constraints. In a given problem situation, defining the key decision variables are important. Identifying these variables helps us to develop the model. The decision variables, objective and constraints are identified from the problem. Developing a suitable model. A model is a mathematical representation of a problem situation. The mathematical model is in the form of expressions and equations that replicate the problem. For example, the total profit from a given number of products sold can be determined by subtracting selling price and cost price and multiplying the number of units sold. Acquiring the input data. Accurate data for input values are essential. Even though the model is well constructed, it is important that the input data is correct to get accurate results. Solving the model. Solving is trying for the best result by manipulating the model to the problem. This is done by checking every equation and its diverse courses of actions. Validating the model. A validation is a complete test of the model to confirm that it provides an accurate representation of the real problem. This helps us in determining how good and realistic the solution is. Implementing the result. Once the model is tested and validated, it is ready for implementation. Implementation involves translation application of solution in the company. Close administration and monitoring is required after the solution implemented in order to address any proposed changes that call for modification under actual working conditions. Let's discuss about matrix algebra determination. A matrix is a collection of numbers ordered by rows and columns. It is customary to enclose the elements of a matrix in parentheses, brackets or braces.
By now, I'm sure you know that in just about anything you do in life, you need numbers. In particular, though, some fields don't just need a few numbers, they need lots of them. How do you keep track of all those numbers? Well, mathematicians dating back as early as ancient China came up with a way to represent arrays of many numbers at once. Nowadays, we call such an array a matrix, and many of them hanging out together, matrices. Matrices are everywhere. They are all around us, even now in this very room. Sorry, let's get back on track. Matrices really are everywhere, though. They're used in business, economics, cryptography, physics, electronics, and computer graphics. One reason matrices are so cool is that we can pack so much information into them and then turn a huge series of different problems into one single problem. So, to use matrices, we need to learn how they work. It turns out you can treat matrices just like regular numbers. You can add them, subtract them, even multiply them. You can't divide them, but that's a rabbit hole of its own. Adding matrices is pretty simple. All you have to do is add the corresponding entries in the order they come. So the first entries get added together, the second entries, the third, all the way down. Of course, your matrices have to be the same size, but that's pretty intuitive anyway. You can also multiply the whole matrix by a number called a scalar. Just multiply every entry by that number. But wait, there's more. You can actually multiply one matrix by another matrix. It's not like adding them, though, where you do it entry by entry. It's more unique, and pretty cool once you get the hang of it. Here's how it works. Let's say you have two matrices. Let's make both of them 2 by 2, meaning 2 rows by 2 columns. Write the first matrix to the left, and the second matrix goes next to it and translate it up a bit, kind of like we're making a table. The product we get when we multiply the matrices together will go right between them. We'll also draw some grid lines to help us along. Now, look at the first row of the first matrix and the first column of the second matrix. See how there's two numbers in each? Multiply the first number in the row by the first number in the column. 1 times 2 is 2. Now do the next ones. 3 times 3 is 9. Now add them up. 2 plus 9 is 11. Let's put that number in the top left position so that it matches up with the rows and columns we used to get it. See how that works? You can do the same thing to get the other entries. -4 plus 0 is -4. 4 plus -3 is 1. -8 plus 0 is -8. So, here's your answer. Not all that bad, is it? There's one catch, though. Just like with addition, your matrices have to be the right size. Look at these two matrices. 2 times 8 is 16. 3 times 4 is 12. 3 times... Wait a minute. There are no more rows in the second matrix. We ran out of room. So, these matrices can't be multiplied. The number of columns in the first matrix has to be the same as the number of rows in the second matrix. As long as you're careful to match up your dimensions right, though, it's pretty easy. Understanding matrix multiplication is just the beginning, by the way. There's so much you can do with them. For example, let's say you want to encrypt a secret message. Let's say it's math rules. Though why anybody would want to keep this a secret is beyond me. Letting numbers stand for letters, you can put the numbers in a matrix and then an encryption key in another. Multiply them together and you've got a new encoded matrix. The only way to decode the new matrix and read the message is to have the key, that second matrix. There's even a branch of mathematics that uses matrices constantly called linear algebra.
A vector is a special type of matrix that has only one row called a row vector or one column called a column vector. Below, A is a column vector while B is a row vector. A scalar is a matrix with only one row and one column. It is customary to denote scalars by italicized lowercase letters, example x, to denote vectors by bold lowercase letters, example x, and to denote matrices with more than one row and one column by bold uppercase letters, example uppercase x. A square matrix has as many rows as it has columns. A diagonal matrix is a symmetric matrix where all the off-diagonal elements are 0. Now we will know about matrix addition and subtraction. To add two matrices, they both must have the same number of rows and they both must have the same number of columns. The elements of the two matrices are simply added together, element by element, to produce the results. Matrix multiplications. There are several rules for matrix multiplication. The first concerns the multiplication between a matrix and a scalar. Here, each element in the product matrix is simply the scalar multiplied by the element in the matrix. The product of a row vector multiplied by a column vector will be a scalar. This scalar is simply the sum of the first row vector element multiplied by the first column vector element plus the second row vector element multiplied by the second column vector element plus the product of the third elements, etc. All other types of matrix multiplication involve the multiplication of a row vector and a column vector.
So welcome to my video on matrix multiplication. And before I get started with this example, I want to talk about the sizes of each matrix, because not every matrix can be multiplied by another matrix. So let's take a look at the size of this first matrix. In this first matrix we have 1, 2 rows, and we have 1, 2, 3 columns. So this first matrix is a 2 by 3 matrix. 2 rows by 3 columns. And if we take a look at the second matrix we're multiplying, we have 1, 2, 3 rows, and we have 1, 2, 3 columns. So this second matrix is a 3 by 3 matrix. So in order to multiply two matrices together, the columns in the first matrix must equal the rows in the second matrix. So in other words, these two inside numbers must be the same. So it's really important to check this before you multiply matrices. If these two inside numbers are not the same, you cannot multiply the two matrices. So after you make sure that your inside numbers are the same, then you can take a look at your outside numbers, and I'll draw some arrows to point to the outside numbers. And the outside numbers will always give you the size of the new matrix after you're done multiplying. So since the outside numbers are a 2 and a 3, we know the size of the new matrix after we're done multiplying is going to be a 2 by 3 matrix. So let's just get started right away with this example. So basically what we're doing when we multiply two matrices is we're multiplying the rows of the first matrix by the columns of the second matrix. So I'm going to put a box around the first row of the first matrix, and I'm going to put another box around the first column of the second matrix. And just to make things a little easier to see when we multiply, I'm going to circle the first number in the row in green, and I'm going to circle the first number in the column in green, and I'm going to circle the second number in the row in black, and I'm going to circle the second number in the column in black, and I'm going to circle the third number in the row in red, and I'm going to circle also the third number in the column in red. So now when we multiply the first row by the first column, we can multiply the green numbers together, which is 2 times 3. 2 times 3 is 6. Then we can multiply the black numbers together, 3 times 1, which is just positive 3. And we can multiply the red numbers together. 1 times 2 is just positive 2. So now we have multiplied the first row by the first column. And now I want to do the exact same thing with the first row and the second column. And the first row is still boxed from earlier, and I'll put another box around the second column. And once again, I'm going to circle the first number in green, the second number in black, and the third number in red. And if we multiply the green numbers together, we get 2 times 4, which is 8. If we multiply the black numbers together, we get 3 times 1, which is just positive 3. If we multiply the red numbers together, we get 1 times 1, which is just positive 1. And now we have multiplied the first row by the second column. And now I'm going to do the same thing all over again. Now I'm going to do the first row by the third column. The first row is already boxed from before, and I'll put a box around the third column. Once again, I'm going to circle the first numbers in green, the second numbers in black, and the third numbers in red. And if we multiply the green numbers, we get 2 times 5, which is just 10. And if we multiply the black numbers, we get 3 times 4, which is just positive 12. And if we multiply the red numbers, we get 1 times 4, which is just positive 4. So now we have multiplied row 1 of the first matrix by every single column of the second matrix. So now we need to do the exact same thing with the second row of the first matrix. So I'll put a box around the second row. And we need to multiply that second row with every column of the second matrix. So I'm going to start with the first column, and I'll put a box around it. And once again, I'm going to circle the first numbers in green, the second numbers in black, and the third numbers in red. And if we multiply the green numbers together, we have 2 times 3, which gives us a positive 6. And if we multiply the black numbers together, we have negative 7 times 1, which is just negative 7. And if we multiply the red numbers together, we have 4 times 2, which is positive 8. So now we have multiplied the second row by the first column. And now we need to do the exact same thing with the second column. So I'm going to put a box around the second column. Once again, circle the first number in green, the second number in black, and the third number in red. If we multiply the green numbers together, we have 2 times 4, which is positive 8. And if we multiply the black numbers together, we have negative 7 times 1, which is just negative 7. And if we multiply the red numbers together, we have 4 times 1, which is just positive 4. So now we have multiplied the second row by the second column. And now we have to do it one last time. We need to multiply the second row by the third column. So I'll put a box around the third column. Once again, the first number in green, the second number in black, and the third number in red. If we multiply the green numbers together, we have 2 times 5, which is positive 10. If we multiply the black numbers together, we have negative 7 times positive 4, which is negative 28. And if we multiply the red numbers together, we have 4 times 4, which is positive 16. So as you can see, these problems can get pretty long and tedious, but now we have multiplied every row from the first matrix with every column from the second matrix. So now the only thing we have left to do is just simplify this matrix and add all these numbers together. In the top left corner, we have 6 plus 3 plus 2, which is 11. In the bottom left corner, we have 6 minus 7, which is negative 1. Negative 1 plus 8 is positive 7. And in the second column, we have 8 plus 3, which is 11. 11 plus 1 is 12. And we also have 8 minus 7, which is positive 1. 1 plus 4 is equal to 5. And in the top right, we have 10 plus 12, which is 22. 22 plus 4 is equal to 26. And in the bottom right, we have 10 minus 28, which is negative 18. Negative 18 plus 16 is equal to negative 2. And this is our final answer. We have completely multiplied these two matrices together.
Matrix transpose. The first row of a matrix becomes the first column of the transpose matrix. The second row of the matrix becomes the second column of the transpose. Matrix inverse. In matrix algebra, the inverse of a matrix is that matrix which when multiplied by the original matrix, it gives an identity matrix. Determinant of a matrix. The determinant is a number that is sometimes used to express the generalized variance of the matrix. Now in the end, let us summarize what we have learned in this lecture. Scientific methods have been man's outstanding asset to pursue an ample number of activities. Qualitative factors are important situations like sudden change in tax structures or the introduction of breakthrough technologies. More recently, LP has been employed in such areas as metal alloy blending, feed blending, ice creamer blending, and food products blending, always with dramatic effect. The successful use of quantitative techniques for management is solving complex problems on time with greater accuracy and in the most economical way. Quantitative technique is a scientific way to managerial decision making, while emotion and guesswork are not part of the scientific management approach.